Hey guys, welcome back to the channel. My name is Zahir, and today we'll be talking about an important concept in essentially making MCP servers secure, or MCP systems as a whole secure, that is adding authentication to the MCP servers. This is part of the series, the MCP labs, or my experimentations with MCP that I'm essentially recording in this particular repo. I have just added this directory MCP auth SSE. You can essentially go through the code here. And if you're not following this, if you've not been following this particular series is part of this playlist on my YouTube channel, MCP. And what I'll be recording will be the fourth video in the series. All right, with that, let's get started. I'm going to show the code now, and I'll walk you through two different authentication implementations. One is essentially using an API key, and the other is JWT. One small disclaimer that I want to add here is that MCP protocol has its own authentication system. Essentially, you use OAuth using a third party or a custom server that you essentially have written, or essentially are leveraging to essentially build an OAuth layer or authentication layer in your MCP solution or system, right? But I'll be using a custom client, and as part of this particular series, we'll be using a custom client and a custom implementation of an authentication system in the MCP solution that we'll see. This is obviously both at the client side as well as on the server side. You will also see that in the future, MCP systems will not just be, a host like a chat application. This could easily, especially in the enterprise, systems or enterprise solution, this will easily be part of a regular full stack application. You can think of this just being a client, just like a database client, connected to different MCP servers. And the kind of implementation that I'll be writing makes it very custom to the internal tools that you will potentially develop using the MCP protocol in the future. Okay. All right. With that, let's get started. We'll start with the simple one. We'll use an API key, which is what most of the enterprise solutions usually have. You could have an API which is protected using an API key, and you need to have access to that API key to essentially make calls to that API, right? So well, let's assume that we have a system like something like that, and we have built an MCP server which essentially leverages or uses an API key for authentication. Okay, so the code that you're seeing right now, this particular file within the directory auth_API key, is something that is already present in the server SSE and MCP server. Yeah, I think MCP server stdio and MCP chat UX stdio SSE. This is essentially the same code for setting up the tools, setting up the MCP server. The only change here is the additional step that we've added is adding a check authentication layer, which essentially reads the headers of the request that is coming in from the MCP client and extracts or essentially reads this particular key API key from the headers and leverages that to essentially do a mapping against this, to check if it's mapping with the secret key that is already stored. What I'm going to do is I'm just going to remove certain pieces that we don't need here. All right, we'll first start with one simple implementation of using an API key as an authentication system or authentication layer. Okay, most of the enterprise solutions, like I said, use this to essentially build that authentication layer. If you look at OpenAI APIs, or Cloud APIs, all of these essentially give you an API key to interact with it, right? Similarly, if you're building a service at an enterprise level, you should definitely have that protection or security layer of adding an API key, at least as an authentication layer. Okay, so let's look at the server that we have built. This tool essentially is something that I'm using from the servers that I've already written here, MCP server underscore SSC. The entire tool that is right from the MCP tools, sorry, the entire code that is right from the MCP tools, the setting of the fast MCP server is exactly the same. The only addition here is this particular method. There's a method called check auth, and what this method does is essentially it looks at the incoming request from the MCP client, and it extracts this particular header, which is basically XAPI key, and checks if it matches with the secret key. And I've obviously written this as secret key, but this could be a highly secured string that you can essentially store in a credential manager like Vault or any other secure store to just validate if the secret key that was passed by the client matches with what you have stored, right? And if it is true, you return true, and the rest of the process is same like how we discussed in the previous videos. And I'm adding check auth here in handle SSC, and handle SSC obviously is called by the route slash SSC when the MCP client essentially establishes a connection with our MCP server. Okay, nothing else. There is nothing. There is no other addition. That's just the simple bit. Obviously, this is for representation only. You should not be writing your API key like this. It should be far more secure than this, but you get the point. We are trying to establish how this would work. Okay, this is on the server side now, and we will quickly run this particular server. I have the code ready, Python MCP client auth SSCK. I'm sorry, I have the command ready. I'm going to run this now. And okay, I don't need to run the client. I'm sorry, I need to run the server. So I'm just going to say MCP server. Oh, I think I have that set up already. So let me just clear screen and Python server auth underscore SSC API key there. This looks good. Oh, I'm sorry, guys. CD auth API key, and I should be able to run the server now. Yeah, the server is running on port 8100. Now let's actually look at the client and see what code changes that we need to make here. If you remember from the previous clients that we've written, the MCP client underscore SSC.py, it's an exact implementation of that. The only change or the only addition that we have made to this particular code is we've added a header. The header is essentially X API key, secret key, and the secret key obviously needs to match with the key that the MCP server is using. And we pass that header to the SSC client like this, just like you would, in an HTTP client, right? SSC client headers is equal to headers that we just created. That's it. And if the secret key is a match, you should have, access to that particular server. Else, you will obviously get an error. What I will do right now is, in the interest of just catching an error, I'm gonna to the client. I'm just gonna add this try catch method to just print the error or log the error properly. Okay. Now let's run this particular client and see what happens. What I'm going to do is I'm just simply gonna change the secret key, and obviously we'll not we want to test what happens if the secret key doesn't match. Okay, so I have the terminal open, the relevant terminal open with the path. I'm just going to run the client now, and let's see what happens. The client essentially is not a chat server or something. It essentially starts running. Uh, it essentially establishes the connection with the server using the SSE client, and if there is an error, it should log the error. And as you can see, the error has been logged, and we are saying that the client, there is a 401 unauthorized error, obviously, because that's what our server does. Let's see what the server is saying. Server is saying the exact same thing, 401 unauthorized, because that's what we are returning here. Okay, so let me go back to the client now. Let me just show you the error so that we know that it's coming from here. Error while making connection with server, unhandled errors in task group. Okay, so I think it's obviously saying it's an unhandled error, but I should be handling that error. All right, that is the 401 error. Now let's actually give it a valid key. So secret key, I'm just gonna give it the same key. Let me show you the server. The server takes secret key. Okay, so let's go back to the client now and run the client again. I've saved it. And you should see that it has started working, and it is going to log the response for both my queries. My query for the second query is essentially, what is the weather like right now in Dubai? And tool response is, the weather in Dubai is currently clear sky with a temperature of 27.15 degrees centigrade. Great. So we have the response for both my queries. The, the client was able to establish a connection with the server using an authentication layer that is an API key, and it was essentially able to communicate with the server using the right API key. And if the API key was incorrect or there was no API key, we would obviously get an exception or a 401 error status code. Okay. All right. So this is with the API key. Now let's use, or let's see how to use JWT tokens to essentially authenticate the MCP solution, both at the client as well as at the server level. Okay. Let me close the API key once, and let's look at the server first. Again, the server implementation is the exact same implementation that we saw here in MCP server, but this time the only addition that we'll be making is the check auth method will be using the JWT token method to essentially generate a secret, to check it against the token that was generated. And essentially, if the token is valid, we return true, otherwise we return these exceptions. We also have added a TTL-like object the uh, to the token, which expires after a given duration. I think it's 60 minutes. So essentially, what we are doing here is the same thing again. Starlet takes in, or the client establishes the connection with the server using the SSE route, which is created by the Starlet application, and this route essentially calls the handle SSE upon invocation. Handle SSE calls checkout method, and it passes a request that is coming in from the client. The checkout method essentially looks for the authorization key in the header and extracts the token that was generated and passed by the client. Okay, now we'll see how the token was generated in a bit. It takes the second element by splitting with space. The token is usually bearer followed by the token, and it passes using the same secret key and algorithm that was used to generate the token in the first place, and checks if the token is valid. If the token is valid and is within and has not expired, the authentication is passed. Otherwise, one of these status exceptions is raised and the status code is written. Okay. Now let's see how the token is generated by the client. Essentially, the token is generated using a very simple technique, which is basically we store the credentials by in this mock client store. You can think of this being coming in using a third-party Auth, server, or maybe you stored this client store in a secured store, and you're using this client secret and ID to essentially create a token. So the client essentially hits this particular token endpoint and uh, passes the client ID and secret. Now, how do you create this ID and secret? You can essentially write this custom endpoint to generate this client ID and secret for the client. Let's assume that that is a manual step that one has to do. You may be on a UI. This is a regular way that these enterprise grade solutions essentially do this. The client generate a client ID and a secret on a UX, and then use that in the code to essentially uh, you know uh, generate a token. That's what we are doing. So let's assume that the client ID and secret has been generated by the client, and they are sending the token request object, which is essentially a pydantic model that is a client ID and a secret as fields. Okay. The first thing that we do is once the token endpoint is hit, is we check whether the client ID and secret is present in the client store. I'm sorry, the mock client store that we've created here. If it is present there, we essentially use the JWT encode object to essentially encode this particular token and generate a token and return that access token to the client. Okay, it's the same secret key and algorithm that needs to be used to generate the token, that is to encode a token. And when you're decoding the token, you need to obviously use the same secret key and algorithm. Okay, that is it is as simple as this. The scope of this video is obviously not to tell you how JWT works. You can look it up. There are several good videos to do that, but essentially this is how we generate an access token using JWT by using the same secret key and algorithm both to encode as well as decode. Okay, the secret key can be very, very different from what we have used. We've obviously used this for representation only, and a secret key looks something like this: my secret, super secret key. You did not. You obviously you could use a very complex one. Okay. All right. So the server was set up. Now we will look at how the client was set up. Okay. We saw that we are using the token endpoint essentially to talk to the token or generate the token, and our SSE URL is the same URL that we have been leveraging. The only difference here uh, between what we saw in the API key method is that we'll be first generating a token and then passing the access token into the headers like this. That is, authorization is the key, followed by the value, which is basically bearer space the auth token that was just generated using JWT, and we pass that in the headers of the SSE client. That's all there is to it. If let's assume that the credentials were right and the token was generated, you will see that the authentication is true. Otherwise, you should get an error. Okay. So let me quickly stop the SSE auth API key server that we was just running. I'm going to come to this particular folder now and type the command. I think I've already typed that. Yeah, so we'll run this particular server, Python MCP server auth SSE JWT. Okay, we'll see. Okay, the server is running on 8E100 port. Now I want to run, let me just clear screen here. I want to obviously run the client, but the first time I want it to essentially pass incorrect credentials. So I'm going to change the client to test client 1. Okay. Remember, we have created a dummy store and that's not what it uses. So let me just show you. We've created this mock store, which takes which has only one client, which is test underscore client. Okay, so let me go back here. I've changed the client ID to test client one, obviously, which is incorrect, or which is at least not present in the store. So this should not work, and we should get the exception. Okay, so I'm going to run it. I run the client now, Python MCP client auth sscjwt.py, and you will see in a bit that failed to get token 401, obviously, because it just was not able to generate the token, because that's the message that we are logging. And the error was unable to authenticate, ensure you're using valid credentials. Good. Um, we know that the authentication works. So I'm just gonna make, or at least send, the right credentials now and see if our tool works. The client is exactly the same client. If the authentication is established or the client is authenticated, then these two queries are run, and we should get the response for these queries. Okay, so let's see if this should work now. And token was successfully generated, and it was able to unhandled error. Okay, I think it encountered an issue somewhere, but it was able to run the prompt correctly the first time, or at least for the first query. The second time it faced an issue. We see, yeah, the response print prompt. Oh, no, this is not the response. Unhandled errors in a task group. Not sure what the error is. Let me see what the error is. Unhandled error in a task group. Am I not printing the errors properly? Yeah, I could see the prompt was printed, but the LLM client essentially was not printed well. You see, if yeah, we are loading the environment variables, which is encountered error, unhandled errors in a task group. Interesting. This is, let's see what this processing request of type 2. Okay. Yeah, the MCP tool is also established. And I can see that the first time the list of tools also came out well. I'm not sure what is happening here, guys. Let's see. Let's go back to the client. Encountered error. The error seems to come from it's definitely able to obviously establish a connection. As you can see, it's printing connected to weather and time server, and it's also obviously printing the schema, the tool. So this part is clear. Interestingly, the LLM client is failing. Let me go to the client again. Okay, it's printing the prompt LLM client. Hmm. Okay, let me just put this try except block and see what's happening. Okay, let's run this again. I'm going to clear screen and should see what happens. Token was successfully generated. Oh, okay, I know what the issue is. Sorry, guys. had VPN issues. So we fixed that. Let's run this again. Successfully generated token, and obviously it's printing the result as we expected. So the what is the weather like right now in Dubai? Tool response is the weather in Dubai is currently clear sky with a temperature of 27.15 degrees centigrade. All right, that's it, guys. That's all there is to this. The code is present already in the GitHub repo. Let me go to the repo. You can go to MCP Auth SSC in the MCP Labs folder. There are two folders here: Auth API key, Auth JWT, and the details are present here on how to run this, and also the playlist included here. All right, I hope this was useful. I hope you learned from this video. If you liked what you saw, please share your comments, share your feedback, share what kind of videos you want to watch, and obviously please like and subscribe. Thank you so much. Uh, we should continue the MCP series and add more videos and experiment more in the MCP realm. Thank you so much, guys. We will connect soon. Bye.